In this topic, we are going to learn about the possibility diagram. First, let's look at what probability is. It is a measure of the chance of the occurrence of outcomes. The probability of an event can be written as this, P brackets E, and it is given by the number of outcomes favorable to the events over the total number of possible outcomes. And the probability of the events E is between 1 and 0, inclusive of 0 and 1. For example, a fair die is thrown, and we ask to find the probability of getting a 6. The probability of getting a 6 is equals to the number of outcomes favorable to the events over the total number of possible outcomes. So the total number of possible outcomes is from 1 to 6, and therefore we have 6 possible outcomes. Now, what is the number of outcomes favorable to these events? Since there is only one 6, and therefore the number of outcomes favorable to the event is only 1. And we have the probability of getting a 6 to be 1 over 6. In this next example, a spinner is made up of 8 equal sectors. It is spun once. If the arrow always lands on one of the sectors, what is the probability of getting a prime number? Here we have 4 prime numbers, which are 2, 2, 3, and 5. And the total number of possible outcomes is, since there are 8 equal sectors, so there are 8 possible outcomes. And the number of outcomes favorable to these events, since there are 4 prime numbers, so there are 4 outcomes that's favorable to the events, which is getting a prime number. Simplifying, we will have 1 over 2. And therefore, the probability of getting a prime number is 1 over 2. We shall now look at possibility diagram. It is used when a random experiment involves 2 stages. We can draw the possibility diagram using axes like this, or we can use a table. And the space here is the sample space. Let's look at an example here. 2 fair dice are thrown, and we ask to find the probability that the product of these 2 numbers is a factor of 24. So, for the first stage, we'll have the first die being thrown, and for the second stage, we'll have the second die being thrown. And the outcomes are 1, 2, 3, 4, 5, 6 for each of the dice. In this sample space here, it is the possible outcomes. Since we're asked to find the product of the 2 numbers, we'll multiply all the numbers here. For instance, 3 times 2 will give us 6 here. You'll then multiply the numbers in each row with each of the number in each column. We'll put the multiply sign here because the question asks for the products. If the question asks for addition or subtraction, you will put addition or subtraction here. Next, we are to identify which of these numbers are factors of 24. Factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. After multiplying the number on the 2 dice, these are the outcomes which are factors of 24. And the total possible outcomes is 6 times 6. We will have 36 possible outcomes, out of which 20 of them are factors of 24. And therefore, the probability that the product is a factor of 24 is 5 over 9 after simplifying. In this next example, a box contains 5 identical cards numbered 1, 2, 4, 5, and 9. A card is then picked at random and it is not replaced. Find the probability that both of the cards picked are prime numbers. So once again, we have 2 stages here as we are picking up 2 cards. So the first card is numbered 1, 2, 4, 5, 9, and the second card is also numbered 1, 2, 4, 5, 9. The sample space here means that the first card is 1 and the second card is a 2. The first card is a 1 and the second card is a 9, and so on. Now you notice that this diagonal space here is empty because it is not possible to pick a 1, 1 as the cards are not replaced. So let's look at this sample space here and see when do we have both numbers being prime numbers. and we have 2 of them. Therefore, the probability that both are prime numbers is equals to the total possible outcomes, which is the denominator, is, yes, there are 20 possible outcomes if you count all the cells in the table here. And how many of these are both prime numbers? We will have 2. And therefore, we will have probability that both are prime numbers is 1/10. Instead of writing down the numbers as in previously, you can also mark them with an X. And you can circle when both numbers being prime. Well, in this case, it is slightly more difficult to see when both numbers are prime. And hence, it may be better for you to write the possible outcomes, for instance, bracket 2, 5 here, to show that the outcome is the first card being a 2 and the second card being a 5. In summary, a possibility diagram is used when the random experiment involves 2 stages. For example, throwing the dice twice or drawing 2 cards. And you can either use X's here or drawing tables. And that's all for this topic.